Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Let me turn on my preview screen. Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Okay, so I'm visible as well as equally audible. So let's start with today's session. Just a sec. Okay, thanks a lot, Ankita. So, 5 people have joined. I suppose that people who were there to come has already joined. Okay, today we would be discussing the problem of yesterday's problem of the day, that is lowest common just a sec just me yeah lowest common ancestor in a binary tree. This question came in Acolyte, Amazon and 313 more companies. Okay, so as it is given in the question itself, this is a tree question. So now let us move to the next question. Okay, so now lowest common ancestor in a binary tree. Okay, we are given a binary tree with all unique values and two nodes with values n1 and n2. Okay, so we would be given a binary tree. Suppose this is a binary tree and we would be provided with two values, that is n1 and n2. So let's write n1 and let's write n2. Okay, the task is to find the LCA, that is the lowest common ancestor of the given two nodes. We assume that either both n1 and n2 is present in the tree or none of them is present. Okay, so good one. So now let us look at what is LCA and what. Okay, so suppose this is the question, this is the given binary tree. So let me write it again. Yeah, so now let us first understand what is LCA. Okay, so LCA, suppose for the node 4 and 5, this is also an ancestor. Okay, let me encircle it with a different color. This is also an ancestor, this is also an ancestor. Okay, now we need to report the lowest common ancestor. Okay, the ancestor which is farthest from the root. Okay, we need to report that ancestor. Good one. Now let us understand what are the ancestors of those. Okay, now suppose let us consider the given ancestor of 4 and 5. So where is 4 and 5? 4 and 5 is here. 1 is also an ancestor of 4 and 5. 2 is also an ancestor of 4 and 5. So we would write here 2. So 2 is our answer. Then 4 and 6. Okay, so now 4 and 6. So we can see that for 4 and 6, this is not the ancestor. Now this is the ancestor which has both as this. Okay, so we are reporting 1. Now 3 and 4 again. Now let us see where is 3 and 4. Okay, 3, this is 3 here and this is 4 here. Now which ancestor is holding both the one? Okay, so we can see that this ancestor is holding both the one and this is the lowest possible. Okay, why? Because this ancestor is holding just 4 and 5, so this won't come into account. So that's why this is the case. Okay, now again 2 and 4. So where is 2 and 4? So let us see where is 2 and 4. Okay, so 2 is here, 4 is here. So which is the ancestor of it? 1 is obviously the ancestor. 2 and 4. Okay, sorry. So now we can see that 2 and 4. This is absolutely very important because here it is treated that a node is an ancestor of itself. Okay, so now 2 is the ancestor of 4 and 2 is also ancestor of itself. So we can say that 2 is the ancestor of both. Now to make this more clear, suppose we have 5 and 4. Okay, so the thing is that this would be the ancestor of both. Okay, for 5 and 4, the ancestor would this be 5 itself. Okay, so I think LCA is now clear. So now let's try solving the question. Now when we see this problem, we can see that suppose we have a long tree. Okay, suppose we have a long tree. Suppose let us draw another tree. Suppose we have this, then we have this, then we have this, and then we have this, and then we have again this. Okay, suppose we need to report the LCA of this one and this one. Okay, now if you start the traversal from the top, okay, now let us just manually do that. Okay, just see the path from this to this. So we can see that we would first go here, we would first go here, we would first go here, then here, then here, then here, then here. Okay, yes, Siddharth, true enough. Now let us see the second one. Okay, now we would again start from here. Okay, again start from here, again start from here, again start from here, again start from here. Okay, and after this would go to this side. Okay, good. Now if you do the dry run for 2 or 3 more binary tree, you would come to the conclusion that the path is somewhat like this. This is also equal, this is also equal, but on the last low LCA, it gets distributed. Okay, it gets distributed. This is like, seems like a funnel one. Okay, so this would be the LCA, because before that the ancestors were same for both, so the pathway is also same for both. Okay, so now this is getting distributed. So what we can do is we can take out the path from the root to the n1. Okay, suppose this is n1, this is n2. Okay, we can take out the path from n1 to n2, and we can take out the path from root to n2, and whenever they both are getting different, then just before that the node would be our value. Let us do the dry run of this. Okay, suppose we want to take the LCA of suppose 2 and 4. Okay, 2 and 4. Okay, so now let us see the 2 and 4. Okay, this is the ancestor of it, so let's take the value of 4 and 5. 4 and 5. Okay, so let's take the value. So first, if I take the value from path of n1, the path of n1 would somewhat seem like this: 1, 2 and 4. We would store this in a vector. And the path of n2 that is 5 would seem something like this: 1, 2 and 5. So we can see that we would first match these two. This is matching, we would move forward. This is matching, we would move forward. This is not matching, so we would just report the initial one. Okay, so this is it. Okay, this is it. Now let us see how we can find the path from root to the n1. This is absolutely very simple. Okay, so now let us first write the function for finding the path. What we would do is we would find the path. If it is present, this would return true. If this is not present, this won't return true. If this is false, we would simply say that yeah, this is false, so there is no node existing, and it is already said that either both of the nodes would exist or none of the nodes would exist. Simple enough. So we would just move what is. Just let me show you. Okay, the base condition I won't showing you again now, but I would be showing you this thing. Suppose we are passing the root. So this is the root, and our target is to find the LCA of 4 and 5. So we would take the same tree so that it becomes absolutely simple. Okay, so first we would find the path from 2, 4. Okay, first we would find the path to 4. If I do the dry run for 4, you would know that what I am doing. So at first, path is having the value first root, that is 1. Okay, that is absolutely 1. So this base condition won't be hit. Okay, so false won't be returned. Then what we would do is we would just push back this one. So yeah, Siddharth, just push back 1, vector 1. Okay, and this vector is passed by reference. Okay, good enough. Okay, passed by reference means the value that is changed here would remain be changed. A copy won't be done. Okay, so good. So now this won't be done. Now if root.data is equals to the value that is given, what is the value? Value is 4. So no, this is not the value. So what it would do is it would go to the root.left. Okay, so just go to root.left. I won't go to root.right because root.right would also go, but that would make a just bigger tree. Okay, so what we would do is, or else let's try to draw a tree. Okay, so let's try to draw. Okay, so here the value is 4. Okay, the root initially is 1. Okay, then so let's root is initially 1, then this is, and r is having the value as empty for now. Okay, we came here, the base condition won't be hit because this base condition would only hit if the root is null. This is not the case. So at this point we would just do it, we would push this root to the vector. Okay, so we are pushing this root to the vector, so now vector would have 1. Okay, so now if root dot data is equals to val, so what is val? Val is equals to 4. No, root 1 is not equal to 4. So we would move forward. Where we would move forward? We would move in both directions, to the left or to the right. Okay, so we would go in 2 directions, one left, one right. So let us go to the left hand side. Okay, so the value would still remain as 4. The root would now be changed to 2, and the array is still having the 1. Okay, this side the root would just be changed, that is 3, and the array would still same. Okay, good enough. Now what we would do is, we would simply move forward. Okay, now we would solve for this one, and then we would solve for this one. Okay, solving for this side, 4 2, no, so that this would not hit the base condition because this is not null. So we would just insert this value. To insert this value, so that, okay, so we would insert now 2 itself. Okay, because we are at the current, so we are just inserting the value of root, and then we are checking if the value is equal to, no, 2 is not equal to 4. Okay, then we would again go to left or right. Okay, so we would go to the left, the value would remain same, only the root would change, left is equals to 4. Okay, and the value is still 1 and 2. Okay, and this side the value would be somewhat like this. Okay, 4, the root would be changed to 5 because this side the root is changed to 5, this side, and then this side it would be 1 and 2. Okay, now this is the case. After coming here, you can see that for both these are 2, 4 and 4 is same, so this base condition is it. Okay, so we would just insert this 4. Okay, insert this 4, and we would return. Okay, we would return, this is done. Okay, this is done, we would return, and this would be our output. Suppose we have suppose this is 5, so still the base condition is not, so still the 4 and 5 is not same, so again 4's left or right would be passed, and that would become null. If null condition is hit, then we would just return false. Okay, just return false, and we would return pop back. So this would be popped back. So this is a kind of backtracking with moving forward. The idea is such that we are moving this side, this side, this side. If we got a path, then we would return from here. Else, suppose we are moving here side, this side, this side. Suppose we got here and we didn't find a path, so we would just pop back the last position. Okay, just say we are moving forward and I made a silly mistake, so I won't start from again. I would just undo my last thing. Okay, so this pop back is acting as a undo for the last option. Okay, so this pathway is clear. Now we would pass the pathway for both pn1 and pn2, and if both are not having anything, so we would just mark it -1 and we are returning it. Else what we are doing is, we are moving forward till both are same. If that is not same, we are breaking and we are just reporting I-1. Okay, just the previous one. Okay, seems clear. Okay, so at this moment of time, just only one viewer is at there. So can I have a quick yes or no from that viewer? Okay, so now moving to the, now what this is doing. Okay, we are doing two traversal. First we are taking out the path for n1, then again we are taking out the path for n2. Okay, taking out the path is taking big O of n and big O of n. Okay, then we are storing 2. Okay, so big O of n and again big O of n. 2 big O of n for space. Okay, big O of n into big O of n plus big O of n. Okay, for space, and time is also still the same. So we can see that we need to do two traversal and we need to keep 2 vectors. Okay, so yeah, thank you, Ankita. So is there a better alternative to this? Can we perform better than this? This is already a ON scale, this is already a ON, but we need 2 traversal. Okay, and an extra space is required. Can we do better than this or not? Okay, yeah, we can do better than this. How and why, I would explain you. So first let me copy this. Okay, let me just copy this. Okay, let me paste this. Okay, so now what I want to tell is, it is given that either both of the nodes would be present or either none of the nodes would be present. Okay, okay. So what we would do is, we would start from the top. Okay, then we are moving this side and we are also moving this side, but first we are moving this side. So now if this is the, suppose this side is equals to either 4 or 5, either 4, suppose we are already taking out the LC of 4 and 5. So once left hand side is either 4 or 5, no it is not, it is 2 and 3, not 4 and 5. So we won't be jumping in, we would be moving deep. Okay, this is 4 and 5. So we would, if we got one value, we would simply return it, else we are not returning it. This is absolutely very simple, but it is hard to understand how this is working and why this is working. Okay, so this is the idea. Okay, if we found a value, we would just trace back, but how this is working, this is absolutely very important. So let us try out the recursion tree and we would understand what it is trying to tell us. Okay, so now we would see that what is the base condition. The base condition is that if root is equals to null, we won't be returning it. Okay, we won't be returning null, then we would return null. Okay, so if root dot data, suppose this idea is 4 and 5, so 4 and 5, n1 is 4 and n2 is equals to 5. Okay, so we would start from the root itself. Okay, at this point. Okay, so let us try writing this. Okay, so n1 is equals to 4 and n2 is equals to 5. Okay, so now the first thing that we would do is, we would pass the LCA, okay, with 1 as root and n1 would be 4 and 5. Okay, so root dot data is not equal to n1, neither it is true. Okay, this is not equal, this won't be executed. So next what we are doing is, root dot L is equals to root dot left, n1 and n2. Root dot right is equals to n1 and n2. Okay, so now this would return what? L and R. So this is going to two direction, L and R. Okay, so we would go to L and R. We are either moving to this side, first we are moving to left. Okay, so let's complete first left. Okay, so what we are doing, then LCA, then we are doing 2, 4 and 5. Okay, then this would again do left. Okay, left and right. Okay, again do left and right. So first left would be completed. So what is the left of it? 4, 4 and 5. Okay, so we can see that the root dot data is equals to n1. Okay, so this would return what? This would return this 4. Okay, so this would return this 4. So this has returned this 4. Okay, this 4 has returned. Okay, here 4 is returned. Now here after this side left is done, now right would be done. Okay, what is right? 5, 4 and 5. Okay, so this is again 5 is equals to 5. So now from this point I would be returned 5. So 4 and 5 is returned from both. L and R is equals to 4 and 5. So this is done. Now this side's L and R would be done. Okay, so now 2 and 4 is done. So now we would again move to this side. This is what? 3, okay, and 4 and 5, okay. Now we would again go left and right, okay, again go left and right, okay. So again go left. Left means what? 6 and 4 and 5, okay. And this, and again left is what? Left of this is what? Left of this is null, okay. If this is null, if the left is null, we would return null, that is we would return -1, okay. From this side it is returned -1. 6, this side is returned -1, this side would also return -1, okay. So now 3 is this side, 3 is this side is 7, 4 and 5. 7, 4 and 5 both side would return -1 and -1. So here also -1 is returned, here also -1 is returned, okay. So -1 would be returned this side, okay. So here we are returning here what? 4 and 5. Here we are returning -1. So here this would be returned 4 and then -1. If any of them is true, we would return true, okay. We would return true, that is the root, okay. Else if it is not that case, we can see that howsoever deep it can go, it would return -1 only due to this base condition, okay. So this is how. And this is the thing, suppose this side is it has returned 4 and 5, okay. So we would either return any of them, we would return the 1, we would return 1, and this side it has came -1, okay. So -1 and 1, it is given that if L is equals to null, we are returning L. So between -1 and 1, we would return 1, okay. Else we would return true, okay. Hey Pankhudi, okay. DB gamers got the idea, okay. Thanks a lot, okay. So this is it. This is how we would be doing the dry run of this, okay. And this is how this is working. How this is working? This is absolutely very simple. But this code, after you know how this is working, this seems absolutely very simple, okay. Okay, good enough. Again, I would be explaining you a little bit. First, we are going this side, then we are going this side, and we found the value which is equal to NNR. So we would just be returning this value, then again returning this value, and we would be returning. If any of the returned value is not equal to null, we would be returning that value, and that would be this, okay. Else, suppose we didn't find the value, suppose we are finding 8 or 9, which is not present only. So we would be returning -1 from this side, -1 from this side, -1 from this side, -1 from this side. This would be reported as -1 only, -1 only, -1 only, -1 only. Again, this would go to the -1, and this would again go -1. So if that is present, this would be given as n. If that is not present, it would be given as -. Okay. So I suppose this is absolutely very simple. If you have joined it live, if any doubts were persisting, then I would have explained. But people are very less in the live, so I would still wait for 1 minute. Okay. So let me know if this code is clear or not, because this code seems very simple, but drawing the recursion, after you are drawing the recursion tree, then this would become simple. Else, this seems a little bit hard to understand. Okay. So let me start a timer for 1 minute. Sorry, I started calculator. Okay. So I would be waiting for the next 1 minute, and if I don't get any doubts, I would be turning this session off. But if you are seeing it after the live stream, then you can search Siddharth Hazra on LinkedIn, and you can send me a request, and you can tell me if didn't you get the idea. I would draw it in a pen and paper, and I would show you. Else I would explain you explicitly. Okay. Now there is a small little announcement while waiting for the next 30 minutes. Okay, so let me know if this is clear or not. Now there is a course on data structure with C++, in which I am only the mentor. Okay, in this course you would know how to master data structures in C++, implementations and all, how to do problem solving upon that. Everything would be done from the scratch itself, starting from the time complexity to the segment trees and all, that is advanced data structures too. So we would go from there to there. Okay, Now this course, after you apply a coupon code of geek 15 week, you would get a cashback voucher of 1500, and you would also get this coupons and all. So the effective price would just be 5299, and you would also get brand vouchers from 16 grams and Biawara. Okay, and this course is valid only till 25th of October. Okay, so 3 more days are left. Okay, so I it seems that everyone has quite understood it. So that's all for today. Thank you and have a nice day.